Okay, so we've read our data into our program. Now it's time to actually do something with it. In particular, plot it with error bars and add labels and play with the formatting and generally get nice high quality plots suitable for publication or inclusion in reports. Okay, so let's have a go at doing this. First thing we're going to need is some data with uncertainties. So we go into our Google Drive and we see our spreadsheet with the data. So in the My Drive/data, click on this, and you can see here's one I edited earlier. I've put in some new columns, the uncertainty in the time and the uncertainty in the distance. And notice I've given it different values for different points because I can, and that's something that can be handled quite nicely with Python plotting. Okay, so we've done that. Let's go back to our program, run the first cell to mount the drive so we can access the file. In this case it's already mounted. It seems to ask me whenever I do it for the first time in a new day to give a whole bunch of permissions, and that's fine, just say yes, give it permission. Now we're going to need to import the pandas package as before, which allows us to read and write the data, but we're also going to need to import the plotting package. This is matplotlib we're using for plotting, and we're going to use the import as command. This imports this but gives it a shortcut name, so we don't have to type matplotlib.pyplot. whatever it is all the time. So let's run those, wait for that to finish. Okay, now let's read in the data, and we'll show the head, data.head, just to make sure it's read in correctly. Shift enter on this, chug chug chug, and there we go. So it's read in the data with all the different columns. Looking good. Okay, time to plot it. So the command for this is plot. It's in the matplotlib package, so you type plt.plot. We need to label what our x data is going to be. So this is going to be data.time, meaning the time column from the data set called data. And then we're going to have data.distance. You can see it often comes up with these guides to the format of a particular thing, which is often be quite helpful if you've forgotten the syntax. We're also going to need to give it the format. What you do is put in quotes, something telling it what sort of points, whether you want to plot line or dots or crosses or circles or something like that. We will plot, let's say circles, so that's an O, and the colour. K for black, R for red, B for blue, G for green, etc. Let's go B, and shift enter to run that. Chug chug chug, and there you go. That's our data with blue circles. Now, of course, this is a very incomplete plot. We're going to need to at least label the axes. So we do plot.xLabel to label the x-axis. Let's call that time, seconds. Run that. When programming, it's always worth running it over and over again. There's no need to type a huge amount in and then just run it in one go. You can test it after each little bit to make sure everything's working. It's usually good practice. Let's do the y label, plot.y label. And try running that. That's all looking good. We can save the image. So this is plot.savefig, and give it the name of the file you want to save it as. So trial plot, and we can give it a format. I usually use .png format, but you can use JPEG or TIFF or whatever else you want. It knows what format by what you do here. You also generally need to set the dots per inch, which is to give a high quality plot. So DPI equals 300 seems to work pretty well. That'll give a nice, crisp, good quality plot. Okay, and we shift. Oh no! Now, if I just do this, I won't know where the trial plot's going to go. What I need to do is put it in a directory I understand. So let's put it in the data directory. So I'll copy this, the path to the data directory, and I'll put that in here. So that means that this trial plot.png will end up in the content/drive/my drive/data directory, so I can find it when it's been generated. Otherwise, who knows where it'll end up. Okay, now shift enter on this one. Okay, so now if we go, we will see a plot has appeared here, and we can click on that. And this is actually a plot I produced earlier. There we've got trial plot, that's a new one. So there we've got it, and that's something you can download, insert another document. It's a nice high quality publication ready plot. Right, final thing to do is to put some error bars on this. So instead of the plt.plot command, let's try the plt.errorbar command. So I'll do this all in a new cell. So you've still got a record of the old one. And we're now going to replace the plot with error bar. So as before, you give it the x and y axes. We're now going to need to tell it where uncertainties are. And if you remember up here, it was t-er and d-er. So we'll type x-er equals data.t-er. So it's telling us that the error bars in the x-axis should come from the column data.t-er. And the y errors should come from data.d-er. There's one other change irritating we need. We need to set the instead of just having the format as things in quotes, you need to actually tell it that format equals that for the error bar command. It's not quite the same as a data command. Don't ask me why. And let's finally change the name of the output file we're creating to error plot. Let's give it a go. And there we have it. We have a plot with error bars in both x and y. You don't need both. If you got rid of this, it would get rid of the error bars in the y direction. So if you only have errors in one, that's fine as well. It's blue circles. We could make it, for example, black plus signs. Or red dots. As we wish. And once again, if we go to our Google Drive, then the data folder, because we chose content drive my data/data here, that means it's going to show up in the data, and here it is, error plot, saved as a nice publication quality plot.